the position of the standard work. In the each manufacturer have this kind of the seat for the each production process, such as the technical condition standard. And maybe the each machinery set by the technical standard. These standards decided by the production preparation department, and also the work instruction sheet. Work instruction is a working procedure, and decided by the production preparation department or the engineer for the precisely how to do that. That is we call the work instruction. Firstly, if you heard from the three standardized work set. Oh, and somebody understand. Oh, standardized work set is very similar to the work instruction. It's very different. These standardized work set is very different from the technical conditional standard and work instruction. Technical conditional standards show the technical standard decided by the production preparation department. Work instruction, also the production preparation department decide. So precisely for the how to do that for the each work factor. But the standardized work set means it's like a background is a technical conditional standard. Put on the three standardized work set, put on the technical conditional standard. And work instruction means the three standard work set, it's like spread for many of the work instruction. Okay, this is the positioning of the standard work. You don't misunderstand. Okay, next page, please. And the definition of standardized work here on the left side, and this work method enable to produce good product quickly and safely with no waste by the most efficient combination of the man, material, and machine. You understand? This is a focus on, and quickly and safely with no waste. By the most efficient combination of man, machine, material. Those, so that you understand, these standardized work focus on efficiency, quality, and safety. Okay? And left side, there are three factors for standard work. And number one is tactile time. Number two, work sequence. Number three, standardized in-process inventory. The work required to set up that item above and to be followed. Okay, please open the next page. And the purpose of standardized works to clarify manufacturing rules. Item may be manufactured differently among people. It minimizes the variance and ensures the quality, safety, cost, and productivity. Okay. And number two, to use as a Kiazen tool. If you don't have the standardized work, you can achieve the higher Kiazen. And so that and the standardized work, also the basement for the Kaizen activity. Okay, there you can see the bottom of the expression. You can see as a phrase, if no standard you have, it means no improvement. If you have a standard, you can start to the Kaizen, improvement. That's the meaning. Okay. The next page, please open the next page. And standardized in process. Sorry, could you open the one page back? Okay. And 3 elements of standard work. First one is tact time. And you can see the tact. Tact means and maybe in the orchestra.
Yeah, Muzumoto-san, I am just sharing the screen once again because some lines are coming there.
Okay, please.
Yeah.
Could you open the?
Yeah, I'm opening it now again. You can see it? Yeah, okay. Thank you.
Okay, and can I continue for the tact time? Tact means the conductor, conductor all the time. And it's like a cyclically moving tact. That is the tact time means it's like a rhythmically produced.
Sorry, I think so because of this pointer position, it is happening. So
okay, you can.
I'm not using the pointer.
Oh, no problem,
yeah.
No problem.
Yeah, thank you.
Yeah, I can see I explain by the.
Yeah.
By my voice and for the which
please.
I explain you. Okay, one tact time and it means the tact used by the conductor. The rhythmically move, the periodically move. Now it means that how many seconds for the each component that we calculate tact time. The daily fixed operating hours, such as, for example, we are normally in the manufacturing process, in the component manufacturer, we consider such as the second, such as the 8 hour. 8 hour mean if one shift mean the 8 hour. 8 hour means 3,600 seconds multiply 8. How many in the maybe the 28 800 seconds for the one day, one shift. Divide into the daily required quantity. For example, the 1,000 units, we have to make 1,000 units for the components. In this case, is the 28.8 is the tact time. So each 28.8 you should make one part. That is the tact time. And work sequence. Work sequence will help to bring production at best efficiency. It may not match the sequence of process. You understand that work sequence is not. It's like it's like a part assembling. Part assembly order. In some cases, if one unit combine 3 parts ABC. In this case, firstly you take A, secondly you take B, then thirdly you take B assembly. That is the right sequence. But we consider if product quality is no different, that you focus on the efficiency the first. Okay, we change to the sequence. Okay, take the firstly part C, and secondly part A, thirdly, part B, this is for the completion. That is, we decide for the decide by the efficiency. That is the sequence. Okay. Next page. Please open the next page. Please open. Okay. Standard in process inventory, and you know the maybe you can see the open the next pages. It's like a meaning of the. Please don't use the pointer. Please don't use. Please erase. Okay.
Once again, I just check it. What is the point?
Okay, I don't need any use for the pointer. I explain by my expression. Okay.
Yeah.
This is the meaning of the intake inventory in each process. That is how many pieces the production process is the sequence is the same to the it's like a part flow. If we don't need any same direction as process flow, we don't need any inventory. But if our movement, workers' movement is opposite direction, we should keep the intake inline inventory. Okay, please turn to the next page. Maybe you can see the actual, the upper side. You can see the material A to the finished item A at the upper side. The lower flow, the material B to the finished item B. You can see the material B, it's like forward direction to the product, finished B, 1, 2, 3, 4, 5. If worker, it's the meaning of the worker's movement, worker's order. Which one is the first? Which one is the second position to the work center? Each work center. In this case, 1, 2, 3, 4, 5. This is the forward direction. But in the backing way, backward direction, the 6, 7, 8, and 9, and this is a backward direction. In those cases, you should keep in the on the conveyor or the machinery. You can see automated machinery. Just only we can touch the switch for the movement, so that all the time we need the one inline process inventory. But another inventory we need on the conveyor for in the backward direction. Okay, that is the inline process inventory. Okay, next one. Next page. Okay, process capability table means the indicate production capability. You can see in this case the machine and basic time and the cutting tool. Each machinery has and cutting tool, so that how many seconds for the basic time manual work. They put on the part and put off the part from the machinery. This is the manual work. Auto work means the machinery movement work, and in total finished. And the cutting tool is for example, the sum of the cutting tool, each 300 pieces. After the 300 piece processing, another cutting tool we should change to the new one. In this case, we need 120 seconds. I explain now first column, okay, cutting tool. In this case, you can understand how many pieces for the shift. that I explain you for example, the 800 second, something like that for the seat. In this case is that you can calculate finished time for the each piece and also the replacement time. Replacement in this case is the column first one and 120 second. 100 second divided into 300, so that each piece for the 0.4 second. So that in total, we consider each part made by the 30.4 second in the column left, column number 1, machinery. And in this case, is we can calculate as 947. Okay, 947. Okay. Then you can see the remarks. You can see the solid line and dot line. Solid line means the handwork, and dot line means the machine work. Each machinery has the handwork and machinery work time. Okay, next one. Here is a combination work combination diagram from the process capability sheet. We can see how many seconds for the handwork, and also for example, the step 2. You can see step 2. This is a combination work for the man and machinery. The machine work time is manual work 4 seconds, auto work 16 seconds, and also we can show for the working time as 3 seconds. And for example, you understand by using this combination sheet, and each within the takt time, our cycle time is how many seconds we can see by the visually, and also you can see the left to right, left to upper side. You can see that both are low. It means the wait idling. How many seconds he has idle. For the next page, okay, please. And okay, next page. This is the layout chart. So we call the standard worksheet. You can see the sequence 1, 2, 3, 4, 5. This is the workers' movement, how to move inside of the process. In this case, the number of worker is just only 1. Yeah. In this case, is firstly take a raw material. Secondly, go to the A1 to machinery. Thirdly, B23 machinery. Fourthly, T12 machinery, and go back to the finished item. And you can see, and if you can see the diamond means the quality check, and cross, you can see the cross means the safety caution. Some of the automated machinery, it's very dangerous for the contact with the machinery. Let's show the safety point by the crossing mark. And standard hand carry means I explained you already the inline process inventory. Standard hand carry, you can see in this case is the in total three pieces, and the cycle time meaning how many seconds for the working factor in total time, 30 seconds in this case, and takt time also the same in this case, but normally not so many cases for the like this way. Mostly the task to time is bigger than the cycle time. Okay, next page. And okay, and please, we can you understand, and if you need to make those kind of seed, you have to take the time for each work factor. Each work factor, you take the work factor, and by the watching at the side, you are going to the factory site, and you take the time for the normally 10 times for the each working cycle, and by the stopwatch. Okay, next page is. Now this is the observing time seed. Yeah, we can see the how many seconds for the each work element it takes. We understand by the observing time seed, and also you can see the left below column. You can see 24. 24 is and it's like a shortest and but cyclic normal work done by the shortest time. We decide by the this table. In this case, the 24 is the cycle time, and we decide this work a certain process was done should be done 24 seconds. Okay, next page. And you can see if you make the standardized work, maybe after the completion of the standard work, we should require to the worker to keep the standard work, but some experienced worker doesn't like follow the standard. So that if when you make a new standard, you update standard, you ask to the experienced worker. Maybe the experienced worker have it's like he proud of his work history, so that he have also the many of the practical knowledge, so that you ask to the experienced worker. Maybe after the completion of the standard, maybe he easily follow new standard. Okay, next one. Okay, and if you need work instruction, you feel necessity. Work instruction should be prepared by the production preparation department, and also in these days it's like digitalized manual, and like this way. Also, they prepared for the each workers, so easily and exactly they follow the rules. So yeah, that is if you need it. Okay, next pages. And if you complete the new standard or the updated standard, you should explain to the worker how to do that. How to do that. This is this methodology. Every Japanese higher management company doing like this way for the how to explain the work for the each work element or the working procedure, and based on the TWI, training within industry. Okay, training within industry came from the United States, and normally more than 50 years ago, and to the most of the Japanese big manufacturer intake this methodology for the giving direction to the worker, prepare to learn the before the give concrete procedure. You are firstly the explain roughly to the for the making the foundation, making the foundation for the understanding of the new procedure. And the next one is to explain the works and to show the process by the each step by the visually, then explain the key point. That is step 2 and step 3. Okay, your new worker should try the new procedure by the standard work, and check the result, and explained by the worker, explained by the worker for the point, and by the worker that we understand how much a worker understand new methodology. Then after the transmit the new methodology and updated the procedure for the standard work. We are every week or several days ago, and each day we are follow up the intermittently, periodically, or intermittently. That's the follow up. Okay, next page. And posted towards the ISO for the easy monitoring. You know, those standards work, and these are not shown to the worker. These are standards work to show to the your manager. Manager confirm. If you go to the manager to the each process, manager they'd like to know each process how to realize the efficiency in each process by the checking these kind of the standard work, so that these standard work the direction not for the worker. Worker already know for the each every of the document sheet they know, and also that they follow and continuously, so that the manager should confirm by the watching this kind of sheet, so that this kind of sheet toward ISO side, not worker side. Okay. Okay. The first time for the questioning to the. If you have any question for the, I ask you.
Yeah, participants, you can unmute yourself and you can ask or you can type.
Any question? Chat.
Anybody? Is anything written in chat box? No.
Okay, can I continue?
Yeah, I think so. At the end, then we will take the questions.
Okay.
Okay.
Can I continue?
Yeah, thank you.
Okay, could you?
Yeah.
Okay, thank you. Please open the next page. Okay. Sorry. The one more sheet I forget, the periodic implementation checking, and after the mastering, the worker already mastering the new procedure for the standard work, but you should keep monitoring, such as the periodically, weekly, or daily. Depend on the company culture, depend on the situation, depend on the difficulty, something like that, you decide what time should we monitor each workstation for the periodically. Then check for the some of the work not follow, and it's like violated by the worker. Then you are you should ask the worker to follow the standard. If they don't like follow the standard, you should know the why they don't follow. You have to, firstly you have to grasp the truth, and you have to the fact, and after the afterly you should know the truth why they don't follow. Then if you understand, you should take the action. Okay, next pages, and number 4, big 4, improvement step of the standard work. Clarify improvement purpose, and some of the problem we have, such as we have some of the, we recognize some ways in certain process, or there are some quality problem, and production capacity enhancement requirement, or those are, we clarify the needs. Firstly, clarify the needs. Then we go to the we understand the current situation, go to the production site, observing. Okay, then we prepare the 3 standard work set of the current state. Yeah, if you go to the if you don't have any 3 kind of the standard work set, you should take the time from the working site. Then you prepare for the 3 standards set. Then you also when you monitoring the site, you take the time also you can find what is the problem, find the problem and ways. Then this is firstly you grasp the fact. Then you are considering number 5, investigate cause and problem, promote improvement. We should take off the real cause, and we cannot realize the improvement. So that then prepare the new standard work. This is it's like kind of the standard work centered improvement activity. Yeah, and in our organization, we have this kind of training. In the yeah, each year we have several times for the participant. But it's like a 5 days activity for this kind of the improvement. It's like improvement. It's like a study. It's like an actual study through the site improvement by using standardized work. Okay, next one. And maybe you can see this kind of the bar chart already, and each workstation, each worker has it's like not add value activity. They have some of them are not value, but in some cases necessary, but not value adding. For example, the machinery A to B, and maybe we have some distance. Maybe after the completion of from the A, we have to take to the machinery B. Maybe we need the three steps for the each part. But in this case is maybe easily understand that this is it's like ways. But you know this machinery is very big, such as the 1,000-ton pressing machinery, 500-ton pressing machinery. Well, those cases are not so easily to move to the another place. So in this case, is necessary but not value added. This transportation is not value added. Just in the bar chart, just only 5% is the value adding. Non-value adding, such as the weight, it's like a weighting, such as making the defective product, or some of the searching tools of the chattering with a friend, non-value adding. This is the red area, and so that you can understand how to improve for the direction for the improvement. You can see this is the light green area, the more enlarged, to the yellow area, as much as possible we shrink, more smaller, minimize, and red area we should take off so quickly. That is the approach for the improvement. Next page, please. And 7 ways. 7 ways is maybe you know, and every of you know, this kind of the methodology. The quickly explain you the left upper side, the waste of order overproduction. You require just only the 100 pieces for the certain process, but I have the surplus hour. Okay, I make 130 pieces, something like that. Yeah, maybe there's 30 pieces for the abundant. We should do, we did make 30 pieces, so that we have to make, we have to transfer to the other places for the allocate for the inventory. That is so that the waste of production, overproduction is the very worst waste. Okay. And then second one, the waste time on hand waiting. Just only the waiting, just only the monitoring, watching the machinery, and just only waiting. Easily understand. And in some cases, the worker and all the time moving. Oh, they work so hard, but they are just only the transporting, just moving, not working. Work means that we have to add value. That is the meaning of the working. Okay, and also the waste of the processing itself. Some of the jigs and the fixture, and unstable. In those cases, he all the time sustained by the left side, the right side, both hands. It's also the ways for the processing. If automated machinery and just only the put on the part for the machinery, just only switching the switch on the machinery, it's enough. But in this case, the jigs and the fixture and the band are unstable, so that all the time worker should keep for the sustaining. That is a bad waste for the process. And the inventory waste. I explained already waste of the overproduction. If makes too much, maybe you have to keep the big inventory. The inventory control is one of the representative of the big waste. Okay, next one is the waste of the making defective product. If you are 8 hours, but 20% of the defective, you mean just only the 80% are effective. 20% are waste, okay? And also the waste of movement. And the movement, some of the, it's like turning or the just only the one hand movement or the just only the watching the product movement. Those are all of the waste of the movement. Next page. Okay, and you know the basic principle of motion economy. This, you know, the Gilbreth and industrial engineering and engineer from the United States decide for waste for the motion. Next pages, please open the next pages. Four principles it has, but concretely explained by through the illustration. Please open the next pages. Okay, the left side and the okay, upper left side. This lady takes the part for the long distance. It's like waste movement. Also the right side, and it's like position of the fixture is a obstacle for the her movement, and change to the more smoothly. Maybe the location should be changed. Left side and for the center column, both hands used simultaneously. Just only for the left side, just only the right side for the hand movement is also the ways. It's like both hands simultaneously. It's the ideal move for the movement. It's also in some cases the jigsaw motion and crossing and some of the not rhythmically and also the problem. Okay, and final lowest column, use gravity. You put on the component for the slider, slider, and the slope. The gravity automatically introduced to lower box. That's like though you don't need for the continuous contact with the parts, and changing and standing or sitting many times for the this lady change the okay standing and sitting. In this case, the lady should keep the standing. Also the and this lady in some cases bend the her waist and no good and just only waiting. Okay, no good. Okay, next page. And direction to improvement and manpower reduction. Manpower, in this case, you understand number one, the worker, in this case, is four workers combined one line, talk to time. And you can see the red line. The worker A have some wasting time. Worker B cannot follow the talk to time. Worker C and D also they have some waiting time. We reallocate to the right side, ABCD. You can see the work center worker D have very few work elements. So that if you will be successful, maybe you can eliminate number of the worker, one worker from this process. Okay. Number two, the fluctuation is very important. Fluctuation. If the certain worker have more than 20% of the fluctuation, it just only the 80% of the takt time was filled by the cycle time. Okay, cycle time means actual shortest time. I explained you already. That is the cycle time. Takt time calculate all the time decided by the how many pieces are required by the next process. That is the calculation shift hour divided into the requirement number of pieces. Decide for the tax time. And in this case is so much waste. And it means the number two fluctuation. In this case is the 20%, more than 20% fluctuated for the so that if fluctuation will reduce, such as less than 10%, our the actual cycle time is more allocated to this work center. Okay, next page. Production capacity reinforcement. Check bottleneck process capability table, and the bottleneck, and which one is bottleneck, man or machinery. And you can see the process capability table. I explain you and how many pieces can produce by the machinery, by the process capability table done by this chart. And the second one, and the standard work combination sheet, the bottleneck or machinery or man decided by this chart, and the layout improvement and arrange layout and consider flow of man machine and information, make layout flexible to quantity. Every month you should relocate for the machinery by using the layout chart. Okay, next one. Next page, yes, please. Please open the next page. Okay, and basic pattern. You can see the raw material number 2, 1, 2, 3, 4. You can see this is the working order. Which one is the first? Which one is the two? This like left counterclockwise movement, and inside of the machinery, we can set the moving space, working load. That is the basic pattern. And if you can see the below on the figure, you can see the big machinery combined for the process. In this case, you can allocate, you can divide near the big machinery, and you can see take the conveyor for by the dot line. You can see the conveyor to the round circle to the here is the number 9, and for example the number 7 worker should go to the number 7, and number 8 then number 9 put on the machinery by the conveyor, and number after the number 9 go back to the taking from the machinery, and after the machinery process, and we take the part to the workstation number 10. That is so that we combine and movement area for the this decided area. This is more efficient for the worker movement. Okay, next one. Finally, we decide for the efficiency when the one piece flow line. You can see in this case is this example the line efficiency. And if you can, and this example 30 seconds. If 30 seconds and multiply and 820 is finished good item. If you can allocate 450 pieces for the 400 minutes for the 400 minutes multiply 20 seconds. It means the total in total shift working time, and divide into the it's like upper of the multiply for the meaning of the working time. It's like and below of the line. It means the working time. The over upper is it's like a net working time. The given working time. In this case, is the 91% of the words occupied by the work. Okay, next page. And you understand the cycle time. And in this case, is the worker A to G. And work center C is the bottleneck. And so that line speed, in this case, is the line speed by the decided by the worker C. In this case, is we are line efficiency. Line efficiency is and 39 multiply 1, 2, 3, 4. The 7 workers combined one process. The 39 multiply 7 is a given working time, but upper of the line is net working time. And in this case, 75.1 is the line efficiency. Okay, line balance efficiency. That is we evaluate periodically. We check the and also we are monitoring by the visual method, such as the graph, and continuously our productivity should keep and a higher level. The calculation way that is okay. That is the completion of my lecture already. If you have any question, please ask me anything. Okay, thank you very much for the attention.
Yeah, thank you, Mizumoto-san.
Yeah.
So questions, participants, please unmute yourself, or you can type your question in the chat box. There was hand raised by somebody.
Hello.
Yeah, yes.
Yeah, good evening.
Really, sir? Yes.
Yeah. There is one slide of 3 elements of standard work. Can you go back to slide, please?
Yeah.
Which one?
There is a slide of 3 elements of standardized work.
Oh, okay. 3 elements.
Yeah. No, go further. Yeah, further.
Yeah. Which one? Oh, no.
Go ahead.
More later. Yes.
One more.
One page back.
There is a work Just here. In work sequence, it writes that it may not match the sequence of processes. I did not understand. Can you please elaborate?
Okay. Please open the next page. Next page.
Yeah.
Yeah. Work sequence is it's like 1, 2, 3, 4, like that. Which
Okay.
one is the first? Which one is the second? This is the work sequence.
Mhm.
Okay.
Okay.
From operation point of view.
Yeah,
Okay.
that's right.
Yeah.
Okay.
Okay, thank you.
Thank
Any other
you.
question?
Hello, Archana this side.
Yeah. Please go ahead.
Yeah, sir, I have one query regarding work instructions. So you have shared, this is point number 4, posted towards the aisles for easy monitoring.
Please show me the which one?
Ma'am, can you please open
Yeah.
that slide?
Please open.
Yeah.
Yeah,
Which
please
one?
go ahead. Yeah, next please. Point number 4. Yes,
Okay.
this one. So normally we are displaying work instructions for workers, for operating engineers. So now here you have shared one different point. We have to share these work instructions. We have to display these work instructions for managers. So ma'am, can you please go ahead? This is point number 4. Yeah, this one.
Yeah.
So sir, can you please explain more about this?
Please open the slide.
Yeah.
Sapana-san,
Yeah.
please open the slide.
Yeah. I'm sharing on my screen. Did you able to see that?
I cannot see.
Visible. Yeah.
Slide number 22. Muzumoto-san.
Yeah.
Yeah.
22?
22. So she is asking that generally we prepare the hours instruction for the shop floor people. So here you are insisting for the manager also. So.
Okay. This means this standardized work making show not for the worker. This standardized work should show to the manager. You understand? Manager, if periodically intermittently come to the workshop, because manager should have responsibility and the situation they understand, they know the production site, so that they'd like to confirm each workshop and they are keeping efficient way for the production by the checking by the standardized work sheet. Okay?
Yeah.
That is my
It
explanation.
means supervisor role is to compare standard versus actual.
Yeah, supervisor made this kind of sheet by himself or herself, and manager periodically or the intermittently come to the certain workshop, and by watching, by comparing for the standardized work and actual work between.
Thank
Okay?
you so much, sir.
Okay, no problem. You are welcome.
Yeah.
Thank you very much. Good question.
Sapna, can I add for the benefit of the people?
Yeah. There are last 4 minutes remaining and there are 5, 6 questions in chat. Yeah.
Just to add, this is Dinesh Patak from ACMA. What Mizumoto-san is explained,
Okay.
operator is only to work only, and the manager should check as per the SOP displayed. It may be in the backside of the operator, so that operator will not see that SOP, but manager can see that SOP and he can check by standing distance that operator is working properly or not. In India, we display in front of the operator. We need to modify a little bit. That is the understanding here. Sapna, you can take the. If you have more questions, I think on this you can ask us separately. Sapna, you can take.
Yeah,
the
you can write a mail. So there is a good question, interesting question asked by Nirbhay Muzumoto-san. He is asking that what is the difference between standardized work set and work instruction?
Oh, work instruction is the more, mostly the very it's like very much it's like detail explained by the work instruction, such as what is the point for the work, what is the position of the work, should be where, should be worker, should be put on the hand in the left hand and the right hand, and how to, what is the appropriate action or the movement for the doing like that. It's you know, the work, standardized work doesn't explain detail for the working procedure. You understand?
Yeah, right.
That is this three kind of sheet, how to allocate, how to worker should move by the orderly and efficiently and safely. That is this three kind of sheet focus on the efficiency, and like that. And also the roughly understand where should I check the quality, where should we it's like pay attention for the danger, something like that. Not three kind of seat, and doesn't say anything about precise working procedure. Okay.
Yeah. So we are taking last question of today because last 2 minutes remaining. Is the VSM is the best tool for identification of standardized work? Mr. Ashish is asking this.
And identification.
Is VSM, value stream mapping, is the best tool for identification of standard work?
No. Value stream map means it's like a very big, mostly value stream map is we have a big value stream map normally inside of the factory, such as the supplier to the work. And the process one, it's firstly the stamping process, and secondly the welding process, thirdly the painting process, fourthly the assembly process. Those each process, how many days for the transmitting to the next process, transferring to the next process, and how many days for the keep inventory for the each process. That is
VSM.
defined by the VSM. Not in this case is we focus on the each working process, each process, so that very limited process, such as one worker's process, or just only the 10 workers process, up to the 10 workers, something like that. Very limited work process defined by the this three kind of seed. You understand?
Yeah. Thank you. This is I request you to give the vote of thanks.
Okay, so all the participants and particularly to Mizumoto-san.
Yeah.
I have 2 questions for you.
Okay.
Can I ask you questions?
Okay.
Where from you prepare such kind of very simple illustrative material, and all people are appreciating your knowledge and skills, how simplified version you are teaching, and each people is understanding very well. So I want to ask you a question, how you prepare? This is with your experience, knowledge, and where from this material is coming?
Material is coming in the originally came from the Toyota Motor Corporation.
But your experience is very good, so people are complimenting you, appreciating.
Yeah.
They are saying very good, Mizumoto-san. They have written in the chat box.
Yeah.
So my first question is that you are very good trainer and people are appreciating. So that was the first question.
Yeah.
And second question, people have also asked that what is the next topic and when you are going to conduct the next training program. So these are only 2 questions.
And the next program for me?
People are waiting for you now.
Yeah, I already sent to the your organization the last two.
Yes. No,
Yeah.
there are other people also presenting, but people are very much happy with your program.
Yeah.
So we'll request Kiazen and all that. We'll have more programs of Mizumoto-san in future.
Yeah, of course. If possible, and I will give some another new kind of the element, and I transmit
Yes.
to you.
And so thank you. Today actually there were 300 participants, but the link got some problem. Only 100 people could watch your program. So
Yeah.
actually 200 people were seeing the program on the YouTube live. So we have made the program live. So it was a very good program, and on behalf of ACMA and Sapna-san and all participants, congratulations to my sensei, Mr. Mizumoto-san. It was a very excellent program, and I think we'll be learning in future from you also. So thank you very much. And next time program will be in Japanese time in the morning, so no problem.
Yeah.
Yeah.
So arigato gozaimasu from my side.
Yeah.
Thank you. Arigatou gozaimasu. Namaste.
Namaste.
See you all. Take care. Thank you.
Okay, thank you very much.